Recently, I have been building a new fuzz circuit here, and I've been using these transistors that I pulled out of an old transistor radio from the 1960s or so. And I have a whole set of transistors here, and I've measured them for their HFE and such, and I've kept them, off to the side till I had a project like this that I wanted to build. Now, also in that radio, there were these two audio transformers, and this is part of the speaker driver in the circuit that the signal would come into the primary side. It would go through like a push-pull amplification stage and then off to this other transformer and then ultimately be delivered to the speaker. So I've had these pulled off to the side. I wasn't sure what I wanted to do with them until I got to this fuzz project, and I wanted to build a pickup simulator that normally calls for this transformer, part number 42TM019. And I was reading the stats for that off the spec sheet. And the primary side, which is normally used in this circuit, measures out at 450 ohms, but it has an impedance of 10K. And there's some other stats like the turns ratio and such. But that same resistance value and impedance value I can measure for these two unknown transformers. And I thought, I wonder if I could use these, instead of having to order a part, could I just use the transformers that I've got that came out of that same transistor radio that I'm using to make this fuzz circuit? Okay, so I have my multi-tester here, and I'm going to use that to measure the resistance and the impedance. No, I'm sorry. I'm going to use the multi-tester to measure the resistance and the inductance value for each of these coils, the primary side and the secondary side. Now, notice that these transformers, the red one here has 2 legs for the primary, whereas the green one has 3 legs. So it's got a center tap on this primary. And if I flip them over, the red one has a center tap on the secondary side. And on the green one, there's only 2 legs on the secondary side. So I'm going to do some measurements for these outside legs. I'm not too concerned about that center tap. I'm just going to measure the outside legs. Okay, we'll start off with the red one, primary side. All right, so that gave me a resistance of 341.2 ohms. My inductance value is 12.33 henries. And for the secondary side, outside legs only, resistance is 283.4. L value is 702 henries. Green, primary, 25.9 ohms, 3.13 henries. Secondary side, 1.4 ohms, almost nothing, and an inductance of 0.07 millihenries, so almost nothing. All right, so there's my red one and the Mauser part. Okay, so the issue I've got here is I have a resistance and an impedance for the part that's in the original plans. But for these 2 parts that I just measured, I have a resistance and an inductance. So how does the inductance relate to impedance? That's the next part that I need to figure out. Now, when I'm dealing with a coil, I have a resistance, I have an impedance, which is represented by the letter Z, and then there's a reactance, which is represented by the letter X, and then I have inductance, which is the letter L. All right, so if I have my coil here, when I hold a voltage across the coil, the wire itself acts as a resistor. That's where I get my DC resistance from. Now, when you start channeling a alternating current through here, like a guitar signal or something, that's when we start getting the reaction of the frequency through the coil. What do I know? The inductance is equal to the reactance divided by 2 pi and whatever frequency that I use to measure the impedance. And ordinarily, the frequency for testing like that is 1 kilohertz. So for these measurements that I have for this part number, these Z values were measured at 1 kilohertz. So a DC resistance of 450 ohms and an impedance at 10K for 1 kilohertz is usually what that is. All right. I have my measurements for the inductance from my multi-tester. I can calculate reactance, and then there's a formula for these three where Z squared is equal to X squared plus R squared. I have a case where I know the resistance and the inductance for the transformers I have, and I know the resistance and impedance for the transformer that I don't. How do I get back and forth? Okay, so I know Z squared is equal to that, X is equal to that. Combine these two, that will be equal to X, which is Z squared minus R squared square root divided by 2 pi F. So I should be able to take the Z and R values for that transformer, compute the inductance value, and likewise for the transformers that I've got, I should be able to compute the impedance. So solving that for Z, Z will be 2 pi FL quantity squared plus R squared square root. So for these transformers, I'll be able to compute the impedance. And for that transformer that's called out in the plan, I should be able to compute the inductance. All right. Just spent some time with the calculator going through here, and for a known resistance and impedance value, L comes to 1.59 henries. So for my other calculations, that comes to 19.6, 341.2, 77.4, and 283.702. That one comes to 44.1. Okay. Yeah, those are kiloohms. All right. So just looking at this number, it looks like the primary side of the green transformer is going to be a better fit. Matter of fact, I might even want to use that center tap because that would cut that value in half. But the resistance is very low for such a high impedance. Interesting. All right. So that's the one I'm going to go with. But just for comparison's sake, I will use the secondary side of the red one, which has about twice the impedance and also twice the inductance and about 10 times the resistance. Interesting. Going to be making this original version of the pickup simulator or of the Unbuffer. I'm going to be putting all of this into this Hammond 1591B clear enclosure, and I'm doing this because I don't have a label to put on this thing, and if I see these components inside, I will know what this thing is. I am going to put in this stomp switch so I can have the ability to do a true bypass. All right, so I've got all my hardware, switches, and everything is cleaned up. Now I am ready to start placing components in here. I don't have that much. I've got the transformer and this capacitor to mount in here, and the rest is just going to be wires. I think where I need to start is I'm going to mount the transformer directly to that switch. I am going to use a dab of super glue, and I'm going to glue this to the top of this case. All right, here's how I have this thing wired. Input is on the right side, which is pretty standard. I come from the tip to my 3-pole double throw switch. In bypass mode, it jumps across these two bottom tabs and goes straight to my output. In the effect mode, it comes off of this tab for the input and goes to this bottom leg of my transformer. I've got the tap in this upper leg going to either side of this double throw switch. So I'm either in full coil mode or humbucker mode, or I'm in the tap position for single coil mode. And the output of that comes from this center tab of the switch. That goes over to this leftmost tab on the potentiometer. The center post goes through my 300 picofarad capacitor to ground, and it also comes around directly to the output tab, and then it'll go out there. All right, I'm going to get this thing buttoned up, put on my knob, and give it a test. For the last step of any pedal, this is the ceremonial edition of the rubber feet. All right, I am over here at the pedal board, and I've got my number one guitar here. I'm going through a buffer, and I've got that going into the Unbuffer or the pickup simulator, and then that's going into, right now it's going into the Satisfaction Fuzz, which is of course hooked up to the Everdead voltage sag, and then that goes through the mute pedal and then off to the amp. And I'm going to try a couple of different things. I want to see what difference this thing makes. First off, just on its own. I think that's in bypass mode there. Interesting. I don't notice any difference with that. Get the buffer turned on. Okay, so that's active. It is very, very slight. Almost don't notice anything at all there. Now with the fuzz, it is so very, very slight of an effect. I notice that it just takes off the tiniest amount of a high-end kind of sizzle. Interesting. So it's not a really noticeable effect, but it does seem to change the sound ever so slightly. So the moral of the story for me is this is not going to be an effect that I plan on using a lot, But like most of the utility pedals that I've made in the past, like the mute and the power switch or the effects loop and stuff, it goes into a bundle of tools that I have that I can customize an effect as I'm building things up. For example, I have this fuzz pedal that I'm working on for another video and for another project, and I have noticed that it does change a great deal when I use a buffer in front of it. I actually kind of like the sound better with the buffer. It seems like it has a little bit more sizzle, or it misbehaves in a way that's a little bit more appealing. This is a device that would defeat that. And if I made a fuzz like this for somebody and they liked it with or without that extra chaotic behavior from a buffer, something like this would, fix that issue for them. So the verdict is still out as far as I'm concerned. Let me know if you use the pickup simulator or something like it, or an unbuffer, to improve the sound of an effect that you have. Let me know what you use this thing for, because I'd like to see something that really changes, and maybe I just don't have that right now. So anyway, I will continue my experiments here. Appreciate you stopping by, and let me know your thoughts in the comment sections below. I will have links in the description for like the transparent cases and all the stuff that I use to make this. Anyway, so be sure to check that out, and I will check you guys next time. All right, catch you later.